All right, today we're going to look into blockchain stacks, how they're built, and what they are useful for. So we're going to have a look at one more complex example of blockchain Dapp. What are the ingredients that makes it all tick? And I'm hopefully going to try to explain that on like specific use case. Hi again, my name is Pavel. I run Beaver Codes, which is a channel for blockchain builders. So let's dive right in. So this is a project I'm gonna use as example, which is called Motoverse. This is a crypto game that we're building right now. Let's go in. It's not that important. So what I wanted to show you is how this project could be built. So let's start from the front end, which is the easiest part to like see and understand, I think. Front end is composed of several things. But first thing first is so-called HTML. So what's HTML is this kind of code that you can see right here. Let me see if I can zoom in. I can, cool. So what I've done in my Google Chrome here, I press F12, which brings this developer console, and you can see the elements that this site is composed of. If we look at like this section, for instance, so there is this div, and you can see that it highlights the part that we're looking at right now. So this would be the HTML is the file that your browser reads, and it gives you the structure of where everything is. Now, very tightly coupled component to HTML is actually CSS. How that works is that gives such like styles to what we're doing. And in this view, you can see it down here. It says styles here. So for example, we can see that this div is just a HTML part of like some sort of aggregator or container. So this div has a class called card body, and this is a reference to the styling that needs to be applied to this block. And down here we can see that card body style has a bunch of stuff, including padding. So if we would disable the padding, it would look like this. But because it's kind of nicer, that's why the padding is there. And you can do much more than just like making space around stuff. You can do, yeah, like colors and shapes and even some basic animations. All that is done by CSS. Now you might have heard SAS, SASS, and that's because that's more, this is more like a more powerful tool that compiles down to CSS, but that powerful tool gives you inheritance and some other very nice tooling that you could use. So that would be that. Now when we're talking about HTML and CSS, those are both such called declarative languages. So what you do is you just kind of declare what needs to be there, some like attributes, you set stuff up. But what they don't have, as compared to imperative languages, which is another family of languages, is they don't have any conditions or any loops, or basically no logic. So you can't put any algorithm in them. But we want some algorithms in this. We want some different behavior based on what things happen. So in this case, when I press this button mint, you can see that something changed, right? Like this spinning box started to rotate, and we want this kind of interactive things happening for user because it's kind of nice and it simplifies using the tool. In order to get these things, we need JavaScript. So let's look at what's JavaScript. I'm just gonna kill this for a little bit. JavaScript is a language that makes all the cool things move. So let me skip ahead. I wanted to show you something else as well. While this minting, we're gonna get back to all these processes afterwards. But JavaScript is thing that can listen on different events and change these declarative structures. So we can change the structure here. In this case, the JavaScript opened this pop-up and created some other, structure that wasn't here before, right? Just kind of made it into existence. So that's one application of JavaScript. Another application of JavaScript is, in this case, like this whole animation that you're seeing, that's just a pure JavaScript. What we're doing here is, if we look at, we have this kind of source image, which is parts of the bike, and then we can take, like, let's say engine, paste it in the browser, and then each 10 milliseconds or so offset it a little bit up and down, and if you do that quickly enough, it looks like video like animation. So that's how this animation, for instance, works. But what you would use also JavaScript to do is actually to build a whole page in some sort of library. So you would get use React, Angular, Vue. These are some more popular libraries for doing that. Let me show you an example. So this is, sorry to scare you with code right away, but this is example of JavaScript code. In this case, it's used as part of the React app that composes this whole solution. So, traditionally you would have an app, TSX, which is a TypeScript, and then you have like this thing, which is called GSX, which is kind of reminding the HTML structure, but you would put more stuff into it. We don't need to go too deep, but I just wanted to mention that. And then what's a follow-up thing to this is that we want some way to interact with blockchain. And in order to do that, we need to use some sort of library to do that. And in our case, we use Web3. So I have some sort of context, which again, way too over the scope, and I'm sorry about that. But the idea of this video is to look more a complex example. So that's why I'm doing this to you. So we would use Web3 library. There's also Ethers.js, which is another popular one. And basically you would, construct some object in Web3 library. And then if we go back to that hook that I had, when I press the mint button, this method gets called eventually, and we call this thing, which will send a transaction, submit a transaction to blockchain. And when I send a transaction to blockchain, what's actually going to happen is that my browser here has this kind of plugin here, which is a Metamask plugin. And this Metamask plugin stores my private key to this account, so it knows how to sign a transaction and submit it to a blockchain. And when I press this button, that piece of code that we just saw is going to be ran, and that will submit these requests to this, Metamask plugin. It's actually going to submit this request more broadly, but Metamask's plugin is one of the things that listens on these kind of requests, and it will listen it, create transactions, sign it with the private key that only the plugin has, and get ready to do the work. And then when you submit the transaction, it's just another API call where this transaction is going to be submitted to the blockchain, to one node of the blockchain. I guess in this case it's Infura node. We don't need to go too deep into that, but it's just distributed on the blockchain. So magic happens. Cool. So when we talked about the smart contract and or the blockchain, actually, here are the past transactions that we've done, and if we look at it in Block Explorer, which is this thing, you can see some stuff. Like you can see that it interacted with this address, which is a contract, and some other things. But how does smart contracts work? There's a bunch of better videos to describe that. I would even say some better in my channel go more deeper into how to build smart contracts, what they are useful and what they are not useful for. So this is one, the Motoverse itself is composed of from like 10 smart contracts at this point. Motoparts is just the tokens in it, the reward tokens, cryptocurrency, I guess you could call that. It's ERC20 token. And this is written in Solidity, which is a programming language you would use to write smart contracts. Solidity was the most popular language to do that on EVM compatible blockchains, but there are some other ones, like Viper in Python is another example. So yeah, again, we don't need to go into what is this doing, but it's just that token code. But because we have this code, now the blockchain underneath this, in this case it's Avalanche, knows what to do when it receives transaction and what to produce. Like when we click the mint button, what happened is that we created the token in the first place, and now we have a token. But that's not where the fun ends, because as we look back here, the token has actually some image associated with it. If you look at the detail of the bike, it has some parameters even. So how does that part work? And you can choose to make this work different ways. But in essence, each token, the smart contract itself, will have a method called token URI, which will give you a link to look for a data about this specific token. So the smart contract only knows this is a token with ID 9, for instance, on that given smart contract. We can do one more thing in this developer tools. If you look at network here, and I'm gonna filter it for the HTTP requests, really. Here we can see that what we're doing here is we going to the specific URL. This is the URL the smart contract returned for us to search for the data about the token itself. So in our case, what we chose to do is host this on Firebase. So on Firebase, we have actually a function. Firebase is one of the many blockchain, Web2 actually technologies that lets you build such functions that are so-called serverless, which means that there's no server serving them. There is a server, but it's not our server. And it just runs a piece of code when this URL is put in your browser. So if I would just copy that, put it in a browser, we get the result, which is just text. There are some data about it. If we look here in this Explorer, that's the same data, but it has this prettify function, so that's why I'm showing it here. Now I'm realizing I probably not see it over my face. Anyways, so we got some description, we get some attributes, and then we use these to populate these tables, right? And one important thing here is the image. So now we got an image link, and if we open that image link, surprise, it's the same bike. But that leads us to the second part, or another part of the data storage question. So first thing, what we need to store is the metadata. So it's the actual, this thing, this string. And the second part is the image. The metadata is actually easy to generate, so it doesn't take much time, and it doesn't take much storage. But the image itself can be pretty big, and if you have a big collections, that's a consideration that you need to take into account, because the big image means longer download times. And Web3 answer to file storage would be something like IPFS, which is a fully decentralized peer-to-peer network for storing images. The downsides of that is that it's very slow currently. So that's the reason why in this case we opted up for traditional Web2 solution to this, and we're using Web2 storage. So in this case, it's a Google's storage for images. And there is one big advantage Well, there are several, but one big advantage for that is that we for free get the content delivery network from them. And content delivery network basically means that they have servers all over the world. And each of these servers serves as sort of caching mechanism. So if this if this image is requested from US, for instance, it's going to be cached on that edge server in that content delivery network, and the next person asks it, it's going to get the response much faster. So this all helps for this to be super fast. And this is also an example of trade-offs that you need to consider when you're building your app. Like, do I want to go full decentralized with all the good things that brings to it? Or do I stay more centralized with, you know, all the performance benefits or all the tooling that I have? And in our case, where we're building game, we opted up for more agility, let's call it, and performance. But that's a thing you need to decide for yourself. Another thing that I wanted to mention is indexing, which is another thing you might do. So for example, when we go to this marketplace, there's a lot of bikes here. Well, not a lot because I've just redeployed it recently, but notice how quickly it loads. And the reason it loads that quickly is because we're doing some sort of indexing on this contract. We are not asking for every bike in existence, the smart contract, the blockchain itself, but we have some sort of central database in which we store all that information as well, so that this happens much faster. And we can use a filtering even, without the need to load information about each token. Cool. I'm sorry, I'm aware this was super fast, but this was kind of the intention. So I hope that made sense a little bit. There's a Discord, for my channel. Feel free to go there, ask me for details. I'm happy to talk about any of the topics and go much more deeper if you're interested. Yeah. Until then, have a wonderful day and bye.